Thank you for coming. My name's Robert Reinhardt. This is our inaugural Video Engineering Summit year. This is not part of the Video Engineering Summit, but I just wanted to point out that Jan Ozer and I are co-chairs of that new area of the conference, which is running towards the entrance of this whole wing. Come and stop by if you haven't already. We've got a lot of deep dive technical presentations in that room. But you're here to hear me talk about identifying real-world options for live streaming playback. I keep delivering this session and updating it as necessary from each conference. So I've given this a few times. I did it here last year. I've done it at East this year. And no spoiler alerts, but WebRTC definitely is moving forward. That's probably the biggest, update I would have to say categorically. All my contact information is here. If you want to be able to, grab it now, go, all the slide decks from every session will be online eventually. Sometimes it takes beyond the end of the week, but if you're new to streaming media, actually I always like to ask, how many people are new to streaming media in the room? Well, don't be shy. A lot of you. That's awesome. And it goes without saying that folks on the west side of the country tend to come to this, and the east side. But there are different things that happen in each conference. The exhibit hall looks and feels different at each of these events, and I'd encourage you to try the East conference as well in May. And we had Project Pantos. That was like one of the best kickoffs I've seen here at the conference. Anyway, you don't need me to comment on the conference. Let's go ahead and talk about some of the options I want to review. I might actually do a demo that I'm going to do again during a session I'm doing at the Video Engineering Summit, where I just show sort of a Wirecast RTMP low latency workflow that I've been putting into place with clients. Real world does just mean that we can use it today in our tech stacks. We don't have to wait for browsers to all get along. It tends to be a long curve. I was just at a CMAF session at the Video Engineering Summit where everything looks great on paper, vendors are getting on board, but is it going to be backwards compatible to all sorts of devices? And the answer to that question is usually no. You got to find a wide variety. Well, in order to cast a wide net, you have to have a pretty robust tech stack to support it. These are statistics that I presented last year as well, and I'll just show them again. The trends are only increasing when it comes to, mobile video and just live streaming video. The numbers keep going up. I know that I've been, and I think it's largely a question of access, right? It's not that people don't want to watch live streams. It's just that it might not be easy to get to a live stream. It's nice that even as an organization, Stream Media at least live streams the main ballroom there. You can watch it. Again, that's something that we do at both conferences. But as more and more content providers are able to approach live, and one of my workshops on Monday was about my own live webcasting setup and a lot of the work I do in government for live webcasts. It's just, again, I see that as a growth industry. Anything that's live and live, mainly for, obviously there's sports, and there's always going to be a venue for sports in real-time live streaming, because most people don't like watch a game a week after it happens, right? They watch it live, they might DVR it, but they're still watching it same day. I think when it comes to the types that I would say social media is a huge driver, and that's what I'm on that last point, that people are now getting used to through social media, consuming live streams and having that engagement with the live stream. And by engagement, I mean being able to be angry or liking it or loving it, and that kind of interaction during live streaming during a live event can be very helpful to the people that are distributing information or the content that's going on there. Some of my statistics, this is just sort of a little jokey slide that 100% of my clients, I should probably update that to maybe 95% of my clients. There's a couple of clients I have that are exploring WebRTC, but they haven't released those products yet. But for stuff that's shipping today, the vast majority, if not all of them, are using RTMP and HLS as their primary drivers of delivering that, or transports for delivering that content. And of course, none of them like to think that Flash is part of it, and it really isn't, right? I mean, Flash has gone, but the components of Flash are still there, right? If I am broadcasting in RTMP and I want to have RTMP playback, well, on my mobile app, I have to make sure I have an RTMP library that can decode it, and lots of folks don't even know that you can do RTMP on a device. Facebook uses RTMP for all sorts of ingest and playback, and of course, you can remux RTMP into other RT transports like WebRTC and RTSP. So let's just go into each of these categories and just sort of look at the pros and cons, if you will. HLS and Dash, of course, are our two HTTP streaming formats. During the CMAF presentation, he brought up HDS and Smooth. It's been a while since I've seen a Smooth deployment, but they do exist. I mean, anytime you have a proprietary delivery channel, set-top boxes are a great example, where there are vendors like LG that support Smooth, and especially with DRM. So you might have these very specific cases where live streams are still delivered over other formats that we think of as effectively dead. And as we've talked about it several sessions here at the conference, the main drawback to any HTTP streaming is the tendency to have higher latency. Of course, there's all sorts of solutions on the market, many of them in the exhibit hall. Oliver from NanoCosmos came up to me just before the session because he wanted to show me some of the new things that they're doing at NanoCosmos for low latency HLS streaming. But for the most part, you're not, even if you are doing low latency, you're only going to do it for one-to-many broadcasts. It's not likely that you're ever going to get the latency low enough to a sub 1 second where I'm going to use it for, say, a web conferencing scenario where I'm going to be talking with one like a Skype or a Zoom kind of session, right? That's just not likely going to ever happen over HTTP. You know, it's interesting to see how HTTP2, Roger was talking about that this morning, how that might influence some of the low latency discussions. But again, we have options that can work today for low latency that don't necessarily need to use HTTP. WebRTC is the big gorilla in the room, if you will. It's been around for a long time, and this is, I came from the world of Flash. I did a lot of Flash development when Flash was popular, and one of the great things about any of those environments was that as soon as there was something new in that environment, I knew that it was going to be available to an audience worldwide within a year's time, right? So if a new feature came out like H.264 support, boom, we knew it would work because there was a plugin that got distributed pretty quickly around the world. Well, obviously with standards take a while to evolve, and let alone not just from their specs, but to their implementation. So not everyone's using the same APIs still. I know Firefox is catching up. I actually have a client right now that's in the medical space that is doing a WebRTC implementation, but it's one of those sites where when you go to use the service, it's like you have to use Chrome. Like they just don't want to worry about, he doesn't have the resources at the time to, for his team to worry about multiple browsers and fixing all the WebRTC issues that might pop up on one browser versus another. So I recently wrote a column in Stream Media Magazine. You can read it online if you want. It's available now online too. About the pioneering tax that WebRTC is going to bring along with it. There's just not, it's funny, if you search for open source libraries for WebRTC, you're going to find a lot of outdated libraries that aren't necessarily going to be part of the latest and greatest WebRTC APIs that are available in browsers. One of my beefs with Wowza, which I'm a big fan of, if you've seen me talk at other sessions, I use Wowza almost consistently across my server installations, although I do plenty of other server installations as well, starting to use Red 5 more in WebRTC implementations, mainly because Wowza I don't want to say they've dropped the ball with WebRTC, but they're not giving it the prioritization that I think it needs. Again, I'm nitpicking with them on that one, but WebRTC is the future. I mean, there's no doubt, and we're going to have a really good WebRTC session with a bona fide PhD giving the session about WebRTC this afternoon in the Engineering Summit. So if you want a deeper dive in WebRTC, I would recommend that you come to the WebRTC session this afternoon in the Video Engineering Summit. It is in the afternoon, right, Jerry? What time? What's the time slot for? Sorry? 1:45. So at 1:45 today, if you, we're going to be having a deeper dive into WebRTC over in the Video Engineering Summit. And the biggest drawback I still find with WebRTC, and again with this medical client that I've been working with for over a year on their implementation of WebRTC, is just the whole VP8 versus H.264 stack. So sometimes their recordings are, sometimes if the user's broadcasting from their computer and they're on Chrome, it might be using VP8, it might not be using H.264, but it's really just converting everything at the end of the day, because they want to record everything they're doing on WebRTC, taking it to a common format. We all know that VP8 is not something that's going to play on iOS, so if he wants recordings to work across devices so that people can review in the medical space what he's doing with this platform, then converting becomes a necessary evil to make what a WebRTC solution work. And potentially transcodes on the fly if you're live streaming in VP8 and you want to go to a big audience. Again, WebRTC can, I could have a WebRTC session with like 3 colleagues, but if I want everyone to watch what we're doing, they don't have to watch over WebRTC. I could take that WebRTC, aggregate it, do some compositing with things like FFmpeg on the cloud, and then push out an HLS of that presentation. So if I was doing a panel here virtually, I could do that over WebRTC between the participants, and then if I wanted to convert that to HLS at a server level, and then, you know, we could mix and match these technologies. Again, that's in a one-to-many sense. That way, we're going to have a lot of, there's going to be latency on my broadcast in this fictional situation with panelists, but again, the latency is not going to matter so much for just people participating. The questions, of course, if they're submitted in a text chat kind of thing, could you know, be behind, but you can get, it's not hard, just so you know, to get HLS down to 6 seconds. If you're using a 2-second keyframe interval and chunk size on something like Wowza, you can easily modify Wowza's packetization settings to have a 6-second latency. I have a client in the medical space, different client, that is doing a sub 2-second latency with HLS on Wowza. And it's large, I mean, they have a very simple video stream. There's no audio, so the bit rate's super low, and they can get away with a lot of keyframes that you wouldn't necessarily pull off with even me as a talking head. So there are caveats to getting HLS at a very low latency. RTSP, this is interesting. I was actually talking with Chris Allen at Red 5 Pro about how they use RTSP in their mobile SDK. I find that RTSP is likely, you know, at a low level is going to likely supplant RTMP for a lot of mobile playback implementations. It already is there. RTSP as a protocol, Apple's been behind it for a long time. So getting RTSP to work in a mobile app environment, again, RTSP is not typically available in browsers. If you're on Android and you present an RTSP link, it might launch an external media player to play that RTSP, but it's not using the browser stack to render that RTSP stream. Even though WebRTC does borrow heavily from RTSP concepts and constructs, they are different things under the hood. But RTSP is something that, again, when it comes to mobile, when it comes to a lot of IP cameras, which I mentioned there too, for a lot of civic government work that I do in setting up webcams for municipalities, whether it's intersections, pools, or parks, those typically are access cameras. Those are all RTSP. RTSP going into something like Wowza and RTMP out. Again, low latency isn't something that they need in those situations, but they don't want it to be super behind. I mean, if it's a traffic cam and people want to see what the traffic's like, is 30 seconds going to make or break whether or not they go out on that highway or not? Probably not. So it doesn't necessarily have to be low latency at the end of the day. The problem, I glossed over it with WebRTC, I'm not going to back up, but with RTSP, one of the reasons I like RTMP is its port simplicity. It's all 1935. I publish over 1935. I play over 1935. And most corporate firewalls these days have already gotten used to a flash world. As far as I know, they're not removing RTMP firewalls. Whereas WebRTC and RTSP, ideally, they're doing TCP and UDP. There's a TCP handshake. Frames are going back and forth with UDP, but if there's any port blocking on UDP, what if a network only allows TCP? WebRTC does allow for fallbacks, but the same things that haunt TCP with low latency delivery are going to come back at that point if you don't have UDP available. So again, on paper, I think WebRTC and RTSP, any of the stacks that are going to move beyond RTMP, they look great. I do work. I mean, because we're at such this turning point with WebRTC, I worry that when any client of mine or anyone else that is trying to explore this space with WebRTC, that they might have issues with firewall restrictions. I might actually pick on Jerry. Is that something that you hear? I mean, like in testing, do you encounter firewall issues? Yeah. So. Right. So, yeah. And that's Jerry I'm picking on from Millicast, by the way. I've known Jerry a long time, so I just know he's going way deeper into WebRTC than I have yet on a low level, so he and his team. And again, he'll be on that panel. Yes, Phil?
So the issue with the networking isn't the port thing, it's just what is different with UDP?
Oh, well, just people might be blocking it on their networks. Yeah, yeah. So it just, yeah. They can't connect over it and share, so you're just restricted to it. It'd be, I mean, for us Flash devs, I mean, I'll never forget like the pain that we went through with RTMP, right? I mean, like there was nothing like, I mean, like when I was at Schematic here in LA and we were building for Disney and like, some higher up at Disney's like, I can't watch it on our own firewall. And it's just like, yeah, Disney, you have a really strict firewall, but rest assured the masses are likely going to get it. That wasn't, something they'd want to hear, right? But that was early on in the RTMP days, right? And that's why I say RTMP now has been around so long that most firewalls are allowing it. So if, again, like if you've got a sophisticated stack, you can probably compensate for lack of firewall availability. But and as we know, public Wi-Fi is sort of wide open. I mean, sometimes public Wi-Fi will lock down. I can't always use a VPN connection when I'm on public Wi-Fi. They might be blocking VPN type of port access. The other thing that because of that port management issue, I would just say compared to RTMP, it may be more difficult to scale your solutions because sometimes there's a randomized port that's selected during those WebRTC handshakes. So how many ports do you need to have open? How many clients do you need can be supported over those socket ranges? It adds a whole new level to your load balancing problems that you'll have to share. Whereas again, with RTMP, I don't have to worry about that, right? I just have 1935's open, and there's no sort of dedicated communication over per client per port. And I've already been, talking your ear off about RTMP, and there's just a quick summary of it. I still put in there potential port and firewall restrictions. You never know how that's going to come into play. I mean, there's some really strict firewalls where it's just, they do traffic introspection on those packets. They're only going to let HTTP over port 80 come over. So what are you going to do in those kind of situations, or 443 or something like that? The biggest problem I find with RTMP these days, with the newer toys that we have available to play with, is that it's restricted to H.264. Adobe didn't update the RTMP spec like they did with H.264 to accommodate a new codec. There's no codec support for HEVC in RTMP. And during my webcasting workshop on Monday, I talked about how I have had to rely on an HEVC encode on site to push, and I can't use RTMP for the HEVC. I don't want to use HLS push. I've never been a fan of like trying to push HLS from a device over a network or pull or push with HLS. So the solution to that was UDP broadcasting to a port on the Wowza box, which could could be insecure as well, depending on how you lock that down, that transmission path. But again, like RTMP sort of ends with H.264. So if you want to take advantage of any of the newer codecs that are available on the market, RTMP is not going to be a good wrapper. But the good news is that it's still an H.264 world. For the vast majority of playback and encoding out there, H.264 is going to be just fine. When I was doing my HEVC versus H.264 comparisons, I used to do a session here at the conference where I would show libx264 versus libx265 and sort of show that progression that libx265 was making with compression gains and the speed that it would encode at on a given piece of hardware. And I lost my train of thought with that. What was I about to say about HEVC? That wasn't very good. I was talking about hardware encoders and low latency.
You were doing the comparison?
I was doing a comparison, but it was more just to, that taught me just about some of those restrictions with HEVC, but I was going, so it'll come back to me. I apologize. Well, I can tell. I just turned 45 this year, folks. I'm in a whole new demographic of memory loss, I think, at this point. So we'll see what happens. I've been looking to my peers in this group that I'm now in to, give me some pointers. Maybe I have to start taking more vitamins, but let's move on before I keep digging my grave a little deeper here. The WebSockets is something that we've seen come out. I know that Wowza's low latency solution, ultra low latency solution, has a player tech that uses WebSockets, and WebSockets are not related to WebRTC necessarily. They've been around for a long time, and they weren't exactly designed to push video through, but it's a WebSocket. You can push anything through it, and if you have the ability to then take the data that you're sending over WebSockets, decode it, and play it back, then there you go. So there are solutions that are using WebSockets. Again, not a common scaling solution for video, so there might be a learning curve or a pioneer tax associated with that. And again, these are the kind, just knowing all the protocols and transports that are available, you can take any of this to a vendor and say, what do you support in this stack and what's specific to it? I mean, a lot of the vendors in the exhibit hall right now are in the P2P space, where it's just like, we'll take your HLS stream and distribute it through a peer-to-peer kind of network and scale over WebRTC. There's a few offerings in that market. And then SRT, this is relatively new. I actually have a client that's having some problems with SRT, and it's usually from server to server. So if you're Teradek's got some SRT implementation in their encoders. Wowza's supports SRT. I believe Haivision was the originated that spec and has made it open source. But it was something to replace RTMP. As I was joking with Philip, and I have been joking about how some of these acronyms are poorly chosen, there was already something called SRT in video related to caption files. I don't know why they picked SRT, so that when we try to do Google searches, we might come up with a whole different tech stack than what we're talking about here. But just know if you search, I would just say search for secure, reliable transport if you want to find more information about it. Again, it's meant more for server to server. That's what, as a push target. So I have a client right now that's approached me that is pushing from North America across the pond to Europe, and they're using SRT to connect. And and they were having issues with it because it was a relatively initial implementation by Wowza. And I'm like, why are you using SRT? Like, why don't you just go back to RTMP? He's like, well, we were having issues with RTMP too. I'm like, well, if you're having issues with both RTMP and SRT, I don't think you can blame the transport. It sounds like something else is going on here, because if RTMP is timing out, then you probably have other network problems going on. But anyway, that's just a recent experience I've had with SRT that didn't seem to work out as well. But I do think that what I like about SRT is I haven't really seen this talked about as an HEVC carrier, but since it is a push out of a device, I would love to see a device, and maybe Teradek's already there with Wowza, but I haven't tested it yet. But if I could do HEVC over SRT from a remote location for a webcast, that would be great. But that's not something that I've been like. I certainly, when I open up my Asia Hilo encoder or I open up a Videon encoder, I'm not seeing an SRT path there for HEVC. I did test a cube from Teradek over a year ago that I believe I did not see an SRT update for at the time, so I had to do a UDP transmission as well for HEVC from that Teradek. But this is promising, I think, for encoders and media servers to talk to each other. As far as I've heard it talked about, it is not something that we would be using any day soon for client playback. It's not like I'm going to put some SRT URL in browser, because again, that's a long road, right? I mean, even if Haivision gives a lot of resources to it, I don't think they're going to convince all the all the browser vendors to just magically insert this by next year into their product. So let's talk more about some real-world use cases, problems with two-way AV. I hinted at this with WebRTC. If you've got multiple parties coming together in a web conferencing kind of scenario or an online conferencing scenario, what do you do if you have codec mismatches? Are you going to transcode on the fly so that folks have the same decoder? Or like my other client I mentioned is doing, just make sure they're on the same platform, like, hey, you got to come on Chrome, and then everyone's going to play together nicely there in that environment. That can reduce that kind of thing. The latency, of course, is problematic with any two-way AV. RTMP is not great for a live two-way conversation. It can be done. I wrote a book where I did like two-way chat with RTMP, but one of the biggest problems with RTMP and most RTMP libraries out there is that, as far as I know, there's no echo cancellation support for an RTMP transport on most devices, and so that would be problematic. Most of the RTMP implementations that I've been talking about are one-to-many. We don't have to have two-way conversations. So again, you got to look at what you're trying to pull off. If you want to do two-way AV these days or many-to-many AV, it's likely going to be some type of WebRTC or RTSP solution under the hood, and that's the way you're going to go with that. And I mentioned the replacement, like when I call the replacements, like what is this brave new world that we're now in, where again WebRTC is a spec, it's now finally ratified, and we're seeing an uptick on it. Again, I don't see it talked about a lot in the media. Maybe it's just because it's never something that people put into their press releases. Like, we just released a new WebRTC solution. They might just say, we have a new live streaming solution or whatever. But I put a few companies on this list, many that are here. There's platforms that you can use that have been around for a while, like TalkBox and OpenTalk, Twilio. They've been around for a long time and facilitating audio for the most part, but they're starting to embrace video too. Peer 5, Phoenix, P2P, Millicast. Jerry's from Millicast here. Wowza has their own ultra low latency service. NanoStream has a service. And by and large, what all of these services, they're providing the hosting layer for you, right? So if you want to start doing real-time streaming with the newer tech, it could certainly be a path to a faster MVP or a path of least resistance to get your product out. And the one question that I always bring up to stakeholders on a project that I'm brought into, especially if it's early on and they're trying to do a roadmap of what their product launch is going to look like, is just, well, if you decide you want to switch gears or you want to change something, like, are you tied to that vendor for everything that they're doing for you? Like, is your front end tightly coupled to what they are doing? Because like, if you need someone's SDK to integrate with their service, then I have to either replace that SDK with someone else's SDK. I talked about pricing schemes that seem to be happening in the player space, right? And yesterday when I was talking about off-the-shelf players, I've had more than a few clients come to me that went with trusted player platforms where they were paying $500 a year for their player for several years, and then all of a sudden they came back and wanted to up that to tens of thousands of dollars. And it's just like, whoa, 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 like that's a big jump. So again, I would stress the same kind of business rules for any platform that you might be looking at for live streaming playback over WebRTC or any other kind of protocol that might be proprietary to what they're doing. Just know what you're locking yourself into. I would say at minimum, if you can get pricing that's locked into a current version of their platform so that you're not auto upgraded to the latest platform and therefore you're under a whole new pricing scheme automatically, that, again, I'm not an MBA, I only play a doctor on TV, so your mileage when it comes to how you negotiate with any of these parties to work into your product is going to be largely up to you and your MBAs on your team. But I just can't stress that enough. And of course, I'm more in the business of building solutions out that my clients can own. Again, that's not to say that working with another provider isn't going to help you get to where you need to, but there are a lot, as we march on in this brave new world of real-time streaming, there's all sorts of things that are out there. The biggest problem I find with WebRTC is that the trend seems to be that there's a tight team that creates an open source WebRTC platform, and it's like becomes the darling of the WebRTC industry. Then another company comes, buys that team to essentially make their product go dead. Like I've had that medical client I talked to, he had 2 different WebRTC platforms that got gobbled up by bigger companies, some that were on that previous page. And then they had to end of life that product, so they were left switching it out. So again, you don't know what's going to happen in the business world, but who knows, the team that's running Janus, if that team gets bought up by another that's producing it, then they might have to end of life that open source, or it just will go stagnant. It won't stay up to date. So then you're sort of stuck. You can, of course, have a hybrid. You could go with licensed server tech from Wowza Red 5, or try using other open source media servers to build out your own solution. But again, you're going to pay a pioneer tax for that. You're going to have a much longer development curve. So if you're trying to get something to market within a couple months, building your own is probably not going to be the best way to do that. And that's where I think once we start to see WebRTC implement it at a native API stack, we're like, hey, right, when I want to write in Swift, I can just sort of call this built-in WebRTC library that Apple's made available to me that works, then I think we'll be in a better space. Just like, if I want to play HLS, I don't have to build my own HLS parser on iOS. It's just there. So is Apple going to embrace WebRTC? Who's going to, what set of libraries are going to become those de facto standards that people gravitate to? I sort of came up with this. It's funny, Rob Klug was using the term unicorn job. This is sort of a unicorn job being like one of those jobs where you are just, it's the best job you could ever have. It's low stress, it's high paying. This is sort of the unicorn server or pipeline that I would, ideally you can have some kind of magical ingest that's running on the cloud that can take any input that you're giving it and output anything that you need from it, right? So the real, when it comes down to it, this is typically what I build for real-time architectures. And again, this is more specific to one-to-many architectures, not many-to-many, but usually I'm using a Wowza GPU because they're cost-effective. They can do more transcoding if I need to. I have regional edges that are behind load balancers of different sorts, usually NLBs, network load balancers. If latency isn't an issue, we're going to put CloudFront potentially in front of it for HLS. If we have to do specific RT transmissions going back, then we'll do a combination of Route 53 routing with ELBs and Wowza edges to do that. I work with another cloud dev too, so I put a lot of these skeleton architectures together and then other teams fine-tune them for me. WebSockets is probably something that I I put there as I should have a dash line there. To date, I haven't had to implement a WebSockets player for a client, so most of the work that I've been doing is HLS, WebRTC, and RTMP out of that stack. But that's a quick rundown. This afternoon at the last session at the Video Engineering Summit, I'm going to be doing one of the, if I have time, I think I have time. Do we go to 12:30? Is it, yeah, 11:30 to 12:30? I've been wrapping up quick, wow. So let's go over here, and I'm happy to take questions. But what I wanted to show you, I was just gonna do a quick demo. So, and you're sort of getting a sneak peek at what I'm gonna show this afternoon. So, for this live quiz show that's called That's Right, they're based out of Louisiana, and I'll just go play this slideshow so I can bring it up live. So, oh, it's thinking. Oh, there it goes. Sort of cheating. So, in this scenario, they're using a TriCaster going to a Wowza origin that's on AWS. There's live edge repeaters running on 3 different edges where there's just Route 53 DNS records doing the round robin load balancing, right? So it's not true load balancing, it's just using round robin at a Route 53 level. But when we were only doing broadcasts between 2,000 to 4,000 people, this was good enough to do, right? Again, they wanted to get out to market quickly. They didn't want too much of a crazy cloud architecture. This didn't auto scale by any sense, but we knew that the audiences were going to be much smaller. You know, they weren't HQ size audiences. As we started to move towards larger audiences, we simply get rid of the Route 53 layer that's doing the round robin using a network load balancer on AWS and auto scaling Wowza edges behind the scene. That's where I rely on my cloud dev to do the more sophisticated metrics with the auto scale and scheduling of those auto scales for the quiz connections. But again, this is not only real time streaming, it's sub 3-second latency. I was going to just see here real quick how quickly I could demonstrate that. So you may laugh when it comes to reference players. I use Flash in the browser still as a gauge of how low I can actually get it, right? Because without a doubt, I've built Flash solutions long enough that I know how to dial down buffer sizes. So there's nothing playing on the stream now. So I'm going to go ahead and bring up Wirecast. And typically what I'm going to be doing with Wirecast is just something as simple as this. Can we bring down the lights a little bit so I can see the projection? You don't need to get me well exposed for this. Yeah, that's a little better. So, and because I slept this machine, I find that Wirecast gets a little picky. So let me just clear these layers, push it over here. So I just have this little sample Getty clip, and I'm going to turn on this clock and go ahead and push those. So newer versions of Wirecast, you can just sort of add a clock overlay. So you can see that's my current local time, counting down. And I'm not pushing this yet, but this is using the quiz architecture that I just showed you. I'm literally pushing a test stream to one of the origins I've set up on that end. And so I'm now pushing this stream over RTMP just to show you under the hood here. And this is something that we can't do with that darn TriCaster. I say darn because I didn't spec the TriCaster for them, so I won't bring that up during the session in front of my client, but I'm going to bring it up here. It's not that I'm not a fan with the TriCaster, but they were using the version that has FMLE under the hood for doing all the encodes, and there's just not a lot of options to sweeten that up. And what I mean by sweeten is that I'll just show you here, and we went through some of this stuff in my workshop. Notice I'm tuning to 0 latency. So Wirecast uses X264. I would highly encourage you, if you're doing live broadcasts, to use an encoder. If you're doing it at a software level like I am here with Wirecast, have software that supports X264. That tune parameter definitely shaved off a good second in this broadcast. I might even be able to demonstrate that, but right now I'm using a very fast preset with X264. I'm doing 360 by 640, and that's an important delineation too. That I would love to use a hardware encoder, but most hardware encoders can't do a size that's going to be portrait orientation, right? Most hardware encodes are built to do landscape, right? Like all the sizes are going to be 1280 by 720. I can't necessarily get the portrait orientation just because it's not a mode that might be built into their GPU. It's really going to be probably dependent on your hardware solution. So again, software encodes, and the TriCaster too, because it's using FMLE under the hood, you can do these kind of custom canvases that aren't standard, right? This isn't your standard broadcast, although people love to record vertical video. You've all seen that video that makes fun of vertical video. You should look it up on YouTube if you haven't watched it. It's called Vertical Video Syndrome. It's these hand puppets doing a tirade against vertical video and why people shouldn't shoot vertical video. But anyway, aside from that, I'm now pushing this live stream. I'm not going to log into Wowza to make sure it's there. I'm just going to assume it's all good. And I'm going to go over here to my reference player and refresh it. So again, this is just a Flash Swift that I've built from scratch. I just call it a lightweight, low latency AV player is what I called this thing. I've got some diagnostic information showing up here too. But just to show this, and again, I'm on the hotel LAN network right now. I'm not on the Wi-Fi, but typically what I do is something like this: is I have Wirecast. And then, let me close this one down here. So let's see what our latency is looking like here in real time. So it's higher than it was when I first tested it. So we're looking at about 3 seconds here. It's probably between 2 and 3 seconds. And of course, I'm just going to do a quick screen capture and look at the screen capture. And of course, this is just a really quick and dirty. So it's off just based on the numbers here. So I've got a 3-second latency now. It was funny, over the Wi-Fi in the other room, I had it down to 1. I'll show you my screen capture from just an hour ago. So an hour ago, maybe more people have shown up on the conference and the bandwidth is more congested, but that same exact test I did an hour ago while I was waiting for the next session to start. I had it down to 1 second. So but to date, I haven't, and again, this is hardly ideal in terms of dedicated bandwidth and being in a studio, but that's a quick and dirty bandwidth test, adding a clock to. You can do the same thing with OBS, by the way. I showed that in my workshop, that we can put you can scale a web view into OBS, and you can just point to a browser that's clicking down the time, and then you just sort of compare your windows. Again, this isn't the best comparison because I'm both consuming and broadcasting on the same box, but we can do similar things when we're in the field. Sometimes what I'll even do is screen share with the TriCaster machine and see where it is in its program feed. And obviously there's some latency with me just using TeamViewer or another screen sharing between that transmission, but it's going to be in the ballpark. The latency actually on TeamViewer and those if they're well done with the screen capture drivers, like it's usually under a second if you're in an ideal situation. So I just wanted to quickly show that that's an RTMP architecture that's working. And again, in mobile, I'm going to point this out here just so that you know, if you're trying to build mobile apps, I mean, it goes without saying that GitHub's got lots of repositories around RTMP and video in general. And the one that we found, and I've been recommending this to other folks to try out too, is I think it's KSY, and I'm going to just put on RTMP. Yeah, these are the two right here. So they've got this is out of China, of course. You can use Google Translate, but if you just search for KSY, these are open source RTMP encoders and publishers. This is the SDK that they're using to do the RTMP ingest. So, I can't remember if its API had a buffer setting that we could set super low. Again, just to sort of go back to my output settings here, a trick that I'll often do as well if I don't have access to X264 in an encoding preset, I can do that tuning to 0 latency, is actually using a sub 1 second keyframe interval. So if my frame rate's 30 frames a second, actually using 15 frames. Again, you can make your keyframe interval one frame if you want, but you're going to suffer, of course, on your quality and your bit rate consumption there. So anything you can do to reduce that keyframe interval is going to likely affect your latency based on your, again, it's going to be tied to a few things that may not be exposed to you under the hood with your encoder. But at the end of the day, we want our encoder buffer to be as short as possible. Sometimes that's tied to your keyframe interval, so if you reduce that. But I have seen if you reduce this to 15, again, depending on what you're pushing, you may not see the quality gain. You know, the quality may drop enough that you won't use a shorter than 1 second keyframe interval, but it is something you could try if you're trying to reduce bit rate on your particular system. And that was it. That was the only demo I was going to do that I thought was relevant in terms. There's stuff I'm working on right now that I can't show in terms of WebRTC, but I think that what I have. What's that? Oh, well, the non-flash version would be the app, but I don't have the app sort of tuned to my test stream. So the best, you know, I would also, when I'm testing with the client and they have their app running, I'll do screenshots and try to line up the time. Again, I'll even sometimes just do TeamViewer looking next to it and take a picture of my camera being held up to the screen to just sort of see where those offsets are. Again, that's not highly scientific, but it lets us know if we're way off or like getting closer to a low latency stream. Without further ado, I'll go ahead and open it up to questions. No, I don't need an update for Keynote. Happy to take questions. Anyone have questions? Yes?
Actually, not a question, just a comment. Thank you for mentioning SRT. I just want to correct.
Oh, okay.
One is SRT, as you mentioned, it's targeted for contribution, not for delivery, so definitely not to the browser 100%.
Right.
I do apologize for the acronym. I printed, but you can either find an SRT Dutch, muscle car,
Right.
teletext. So
There you go. I love it.
It's cool though. One thing is UDP only right now.
Oh,
it's
right.
not UDP TCP. We have a mode where we can go instead of LRQ, do NEC, and that will become.
Oh,
actually,
okay.
Maybe more for multicast or unidirectional. But the key thing here is in terms of the codec. It's doesn't know anything about video, audio,
Right.
or whatnot. So it's content agnostic, format agnostic. So half of the deployments are using HEVC, for
Right.
example. So it's using both formats. From a comparison a little bit with RTMP, the main drawback with RTMP that we saw from the customers is that over long distance RTMP becomes a little bit problematic.
Right.
Plus the bandwidth utilization. So that's the main
Right.
areas where people are.
And that's what that client of mine was doing a wowza to wowza over a long distance with SRT. So,
Yeah, so
and
again, a lot of people using, so I invite you
Right.
to the SRT Alliance, take a look, or the GitHub. A lot of companies, Comcast is what they call the live linear. With
Right.
that, media time.
does High Vision have a booth to it or?
No,
But you're here,
probably,
so we can just hound you with
when I
questions.
come to the other talk,
Oh, excellent.
love to, and
Right.
yesterday we had I had a talk here also to just demystify SRT, so hopefully I'll get these slides up and see how we can help the community for sure.
Excellent. Well, thank you.
Thank you.
Any other questions? But you might get a look. Oh, yeah, in the back.
So you said RTMP is going to fade away because it's locked to H.264. I don't entirely understand that. I've used RTMP, but not from a technical point of view.
Oh, I was just saying that as a spec, it's dead-ended now in the sense that, like, you know, we're not going to see it. Like, Adobe hasn't added HEVC decoding to Flash, right? So there, as a wrapper, RTMP has very specific codec implementations. So we're not going to be able to use anything more than H.264 in an RTMP stream. So as far as I can tell, there's never going to be a day where RTMP will let you do HEVC, right? So.
So you're saying RTMP is not format agnostic, for example?
That's right. Like he just said, SRT is. SRT's format agnostic, so it's a transport layer, right? So we can put lots, and I guess that's part. You drafted the spec, so you made it that way, right? So that's fantastic. Yeah. Yeah.
bi-directional.
Right. So I imagine there's still some kind of, I've never looked at you have an open source SRT on GitHub, right? There's some, like if you want to build an SRT layer, your specs are there for SRT, right? So if I wanted to build my own SRT pipeline, I could download the open source on I think it's on GitHub, isn't it? I think.
Yeah, it is on GitHub, and we have full
Right.
documentation there. There's a sample program that gets you up starting very quickly.
Has anyone built an Nginx SRT wrapper?
50 products right now on the market.
Oh wow.
We're an encoder company, but there's a lot
Right.
of other encoder companies
Right.
implementing it. There's many that's driven through it. Pure Vision is standardized on it. And we have 170 people in the SRT Alliance.
Right.
From anybody from Microsoft, Comcast, Pure Vision, Iola, Brightco,
Right.
you name it. Again, it's trying to solve a problem where RTMP is falling a little bit short,
Yeah,
although
yeah.
it serves the community very, very well, right?
Yeah.
But as you said,
Yeah,
in your talk,
yeah,
we
yeah.
need something that works
Yeah.
now.
Yeah.
Right?
Exactly.
So that's
And follow up on that?
I used SRT, I used it because of the FEC. When you transport into a data center, you're gonna drop packets when you
Yeah.
just are. And so using a little light FEC is a beautiful thing when you can't have.
Yeah. That's true enough. Any other questions? All right. Well, thank you again, and enjoy your lunch break and our last day at the conference. Thank you.